Hi everyone, my name is Alyssa. I am with Alberta Environment and Parks in the Operations Division. I work closely with Vanessa. I am a member of the Environmental Management Framework implementation team, so my work is on managing and implementing the water management framework in the Capital Region and Industrial Heartland. So today I'm going to talk about our work past, present, and future on the water management framework. So just a quick overview about what I'm going to talk about today. So just some history on the Industrial Heartland and Capital Region Water Management Framework, how we moved into a load management approach for managing water quality, which included the development of water quality objectives and maximum allowable loads, the development of operational programs, and then what's next for implementation. So Vanessa showed a very similar map, and so this map is of the Industrial Heartland and Capital Region area. So the blue dots that you see on the map are two of the long-term river network sites, or LTRNs, that Vanessa had talked about. The first one is at Devon, and the second is at Pecan. And these frame are what we call the Industrial Heartland reach of the North Saskatchewan River, which is the blue line that you see on the map. And this area is highly industrialized with oil refineries, chemical and pesticide manufacturing plants, power generating plants, 3 wastewater treatment plants, 2 water treatment plants, and numerous storm and combined sewer outfalls. So this creates a great challenge when we're cumulatively managing these facilities to ensure that water quality in the river does not degrade downstream. So the framework for this Industrial Heartland reach, in 2007 it was developed because there was a lot of pressure in this reach with population growth and anticipation of 7 to 8 new dischargers and upgraders. So questions were being asked whether the river could handle that kind of growth, and therefore the water management framework for the Industrial Heartland was developed. So this framework was the first application of cumulative effects management approach in Alberta. So the overall intent of this framework is to better manage water quality and quantity. The framework outcome is to maintain or improve water quality, which is different than use protection, which some other basins in Alberta use. It's not a pollute up to value because we want to see improvement in the river over time. So this framework was developed with significant multi-stakeholder involvement. Our committee is based off the City of Edmonton, industry associations, utility companies, and the North Saskatchewan Watershed Alliance. So this group still meets regularly with Alberta Environment and Parks to advise us on the implementation of the framework. Just some quick regulatory context, that way when I'm talking about approvals, you have an idea of what I mean. Vanessa touched on this too. So the Environmental Protection and Enhancement Act, or APEA, regulates the activities that are happening on the environment to protect and enhance the wise use of Alberta's environment. So APEA approvals detail specific construction, operating, reclamation requirements. So they'll list the emissions or effluent limits that a facility is required to meet and the type of monitoring that they have to do regularly. So we regulate approvals on a facility by facility basis, but the framework itself does not replace this regulation of approvals under APEA, but it supports APEA by providing the water quality goal that we are working towards within this Devon to Pecan reach. So implementation of the framework wants to look at the cumulative impact that all these facilities are making on the river, and we want to look at the water quality of the river moving beyond just regulating on a facility by facility basis. So I work with our approval writers to ensure that they have a working knowledge of the framework, and when we work on approvals together, they understand what the pressures are in the IH reach, and they can support our implementing our operational programs. So an example of this is we develop regional clauses that say if you're within this reach, you know that there are initiatives under the water management framework that you may have to participate in. So early implementation of the framework, initial work was on just communicating, what is this program and what is it doing? So we are also filling science gaps and improving knowledge of the North Saskatchewan River. Vanessa had talked about various studies that went into looking into trends of water quality over time, as well as understanding the state of the river and developing suites of modeling tools. There was a large engineering study that looked at different scenarios for a regional wastewater system, as well as different ways for integrating monitoring to support the framework. So most recently, water quality objectives were defined for the Devon to Pecan reach of the river, and maximum allowable loads were calculated, and all this information is available up on our website, which I can provide the link with to the slides afterwards. So much of our focus to date has been on managing point sources, as they have been the easiest to monitor and manage. However, the framework highlights the need to understand our non-point source contributions, and Vanessa talked about ways in which we hope to fill that knowledge gap. So developing maximum allowable loads has allowed us to adopt this, what we call a load management approach for managing water quality. So our group came up with this definition that's in red there to state what we mean when we talk about load management. So there's kind of three parts to this definition. The first is that a water body can only accept a certain mass of contaminants before water quality deteriorates. And then once that maximum mass of contaminants is known, discharge is managed so that the threshold is not exceeded. And to do that, there are tools and policy to assist in calculating the mass and to prescribe management actions to achieve our social, environmental, and economic objectives. So our end result that we want to see from our load management approach is to put seasonal loads into those APIA approvals. So this diagram shows our current and next steps in the load management process that we've developed for the industrial heartland under the framework. So each step helps to fill in some of the data gaps and to provide management actions to move from one process into the next. And so I'll be going into this a little more detail. But also to back up a little bit, to look at the overall load management approach, it's been going on for a long time. We have set this process with a 10-year outlook, and it's been developed with great involvement from our stakeholders. So the first step that we saw in the process was to calculate the in-stream maximum allowable loads, and then from there, to determine what facilities are contributing seasonally to the river, we are developing our effluent characterization program. Thirdly, we have an effluent management program that has been proposed that will closely monitor the variables of concern that are identified under the maximum allowable loads. And then lastly, we want to put loads for specific variables of concern into the APIA approvals for facilities that would release the significant mass for each of these variables of concern. So now getting into more detail on each of these steps, starting with water quality objectives. So water quality objectives, or WQOs, are expressed as a concentration for a contaminant for a specific location in stream. So water quality objectives were developed with stakeholder input and have been set at both the Devon and Pecan locations, the long-term river network sites, the two dots that you saw on the map previously. So water quality objectives were calculated with historical water quality data. So Vanessa had mentioned that there was a long-term time, I think it was since the 60s. So you take those observed values that you have, and then you can take either your median or 50th percentile and 90th percentile, and those are your water quality objectives that you want to meet at both Devon and Pecan. So they have no regulatory enforcement like a surface water quality guideline would, but they are an objective to work towards meeting within the river. So under the North Saskatchewan Regional Plan, water quality objectives will also be set at the LTRNs, and these objectives will be supported under the Alberta Land Stewardship Act. So the water quality objectives that were set at both Devon and Pecan can be used to calculate our maximum allowable loads. So maximum allowable loads are the maximum amount of a pollutant that a water body can receive while still meeting the set water quality objectives. So they're expressed as a mass per time, so kilograms per day. And maximum allowable loads were developed from the US total maximum daily load, or TMDL approach. So pilot maximum allowable loads have been developed also with stakeholder involvement for both the Devon and Pecan sites for 21 variables of concern, which are mostly our nutrients and metals. Stakeholders have been greatly helpful in calculating these and working towards maintaining and improving these MALs in the river. So once we have our maximum allowable load set, we can work towards quantifying the mass of each parameter that the river can handle, which is key to developing management approaches. So for example, we can find out who is contributing what percentage of total phosphorus that is measured at both Devon and Pecan. So this is a graph of what a maximum allowable load looks like when plotted. So it's based on a flow exceedance curve, and we use it to apply maximum allowable loads. So the green line is your maximum allowable load, which is your water quality objective, multiplied by the river flow and a conversion factor to arrive at kilograms per day on the left axis. And the points that you see in blue are the observed historic water quality values at Pecan. So these are the ones that you would be measured at Pecan. And the blue lines that cross each of the different flow regimes, which are separated out in the vertical black lines, show the median values for each of the flow regimes. So then where the blue median line is above the green MAL line, it means that the MAL has been exceeded and therefore a reduction would be needed in that flow regime. And then the sideways triangles that you see at the top illustrate where management of the sources during the different flow regimes will be most beneficial. So for example, point sources from the combined sewers and storm sewers have a large impact during runoff and wet weather events, which is the same for non-point sources. Wastewater treatment plants and industry have a large effect in the winter when flows are low and there's less of a dilution effect. However, their contribution is usually the same throughout the year because their process doesn't differ. So what we know about the observed loads at Pecan are, but we don't know what the contribution of the municipal, industrial, and point sources are that make up the total. So we developed an effluent characterization program to look at separating these different loads out. So our effluent characterization program, or ECP, was developed for industrial facilities that directly release wastewater into the North Saskatchewan River. A similar program was completed by municipal wastewater treatment plants as an approval requirement a few years ago. So this program was just to figure out what our industrial sources are. And this program is for 1 year to collect 4 seasonal samples to fill in the different points along that load curve that I showed you for a large set of parameters. So the key of this program was to request a representative sample to ensure that we receive normal operating wastewater samples for understanding what our loads are normally. We didn't want to see the rare events because they could skew a median curve. So the program results will help to further the development and understanding of the variables of concern, the 21 that I talked about that were set with the MALs. Will help to recalculate MALs if it's needed, and will also fill in the data gaps for various models and tools that we have for water quality management. So the program accomplished all of this by filling in the data gaps, which are caused by facilities not all sampling for the same parameters at the same time. So we'll see some facilities will only monitor for about four parameters, and others will monitor 10, and they'll be different. So we wanted to get a better understanding of all these large suite of parameters at the same time. That way, it would help us to understand our loads. We also received seasonal samples to fill in the MAL charts because some facilities also only, say, monitor metals in the summer, where we also want to know what the effect of metals are during the winter as well. And it captured new parameters of interest and parameters that may be increasing in the river without our knowledge because we don't monitor those parameters regularly. So currently in this program, we are at the end of it. We are at the last sampling portion. Next, what we want to do is put together a short report on how the program went and how the data can be used to support other aspects of our load management process. So since the ECP filled our seasonal knowledge gaps for all the variables under normal release circumstances, in between the ECP and this effluent management program, work is needed to analyze the data from the industrial ECP, the municipal program, and put together a cumulative effects picture to determine who the major contributors are to water quality and identify those that would participate in this effluent management program. So this effluent management program hasn't entered the scoping stages quite yet, but the program will be developed with participation from our stakeholder committee. So what we think this program will look like is we would like to require facilities to do more frequent monitoring for variables that they are a significant contributor of. So if they are identified under the ECP that they have a large release of phosphorus, then they would provide more data than the 4 points that the ECP provides to use when calculating loads for approvals. And then this regular sampling would also help for other modeling as well. So also we want the facilities to tell us how they can reduce their substantial sources contributing to their load. So the idea is that they would develop a proposal, carry out their management actions, which would tentatively be a phase 2. So we see this program happening in 2 steps, first being the monitoring portion of the program, and then the facility would receive their load based off of the data that we receive. And then if a reduction was needed from the facility for their parameters that they are a significant contributor of, the facility would then carry out their list of management actions. Other areas that are helping us with supporting our water management framework implementation. So Vanessa already touched on the North Saskatchewan Regional Plan. And under the North Saskatchewan Regional Plan will be the Surface Water Quality Management Framework, which is also in drafting stages, like Vanessa had said. But it will incorporate our water management framework for the Industrial Heartland and Capital Region. And a few ways it's done that so far is by adopting the maintain or improve water quality goal for the river. And it will also assign water quality objectives for the LTRN sites, as well as proposing management actions that will be needed as well. Another area that is helping us with the implementation of the water management framework, our policy group is developing a provincial policy on load management. So this is also in a draft form. It will provide provincial direction for the areas that see load management as an appropriate approach for managing water quality. And then within this policy will be guidance documents for apportioning loads, as well as description of how to calculate a maximum allowable loads or any offsets that could be needed. So both these groups will be doing engagement when the documents are ready to be released. So if you want to participate in that, I encourage you to stay interested and included in those discussions. So then just in summary, the water management framework provided the overall water quality management outcome for the North Saskatchewan River. So we want to maintain or improve water quality. So through implementation, we used a load management approach, which was determined to meet the needs of implementation. It has not been simple to implement, and we have a decade worth of work planned and still ongoing. So stakeholder involvement and partnering with other government groups is key for moving work ahead. We need to have buy-in from other teams and stakeholders to get this work going and moving forward. Our policy and planning groups are supporting implementation of our water management framework by incorporating our sub-regional framework into the regional plan and by supporting our load management process by creating provincial policy. Development of the Effluent Characterization Program and Effluent Management Program takes a coordinated approach, and there will always be hurdles to overcome when we're implementing these types of programs. However, if we can stick to this process, we hope that we can be able to put load numbers into approvals eventually.